Hello again, everybody. So next up, we are ready to move on to three-point perspective, the most challenging of all the perspectives for sure. But before we jump into it, I want to take a minute to revisit a rule I gave you guys earlier. It says that all receding lines that are parallel in nature to one another appear to meet on the horizon. And so far, I told you that all vanishing points will meet on the horizon line, right? And we have this book here. It's sitting on the table in front of us. The edges along the length of the book are all parallel and receding, so they will converge at a point on the horizon line. Well, as I mentioned, that's not always true. There are exceptions to every rule. So what happens if I started to turn the pages of the book? These edges of each page are parallel and receding away from us, but where are they receding to? If you try to follow the lines with your eyes, you may notice they're definitely not receding towards the horizon line. So if we follow these lines, you see that because the pages are turned upwards and downwards, they are receding towards points above and below the horizon line. They will not converge on the horizon line. So that means we need to amend our rule here. All receding level lines that are in nature parallel to one another appear to meet on the horizon. By level, I mean lines that are parallel to the horizon. All of the lines we've been talking about so far have been level. This book is sitting flat on the table. So the spine, the book cover, and the pages, they're all level to the ground. So that means they are receding to vanishing points on the horizon line. But once we start turning pages, they are no longer level. They're inclined. And we're going to call these inclined planes. Then each page of the book that we're turning upwards, that's inclined upwards, will recede and converge at points above the horizon. So that means all receding lines that are in nature parallel to one another, if inclined upwards, will appear to meet at a spot above the horizon. And as we keep turning the pages, once we get past that halfway point, we're now turning the pages downwards, right? The pages are inclined downwards, and they will recede and converge at a point below the horizon line. So that means all receding lines that are in nature parallel to one another, if inclined downwards, appear to meet at a spot below the horizon. So that leads us to three-point perspective. And keep all that in mind. In three-point perspective, the one big difference has completely to do with where you are looking. If your head is tilted up or down in any way, your line of sight is up or down, then your form will be in three-point perspective. Because your head is tilted, the height of the cube is no longer parallel to you. The length, width, and height are all receding away. And that means the closest thing to you now is that very corner of the cube. And every single other line is receding away. So three-point perspective only happens if we are looking up or down. And this is what it looks like if we're looking down at our cube. Our head is tilted downwards. First of all, you have to ask yourself, where is the horizon? Where is your eye level? Because you're looking downwards, the horizon line is going to appear pretty high. It's going to be up above your object. And try to see this yourself. Look down at the floor right now in your room and ask yourself, where is your horizon line? And you know the horizon line's at your eye level. Remember, think of this room filled with water. Just because your head is tilted, the horizon line hasn't moved. But because you're looking down the ground, you can't see it anymore. So the only way you actually could see it is if you were to turn your eyes so you're looking upwards without moving your head. So you always have to think when you're looking down, the horizon line's going to be up. And it's really best if you try to see that yourself. And let's go back to our cube here. So the length of the cube is level to the ground, so the lines are receding back to converge at a point on the horizon line over to the left. The width of our cube is level to the ground, so the lines are receding back to converge at a point on the horizon line over to the right. And now, because we are looking down, the height of the cube is no longer perfectly vertical. They are receding downwards to converge at a third vanishing point that is way below the horizon line. And notice how very far away that vanishing point is too. Here's some examples of things you may be looking down at. Pretty much anything on the ground. You have to tilt your head downwards to see. Notice that how we are looking down at everything so we can see the tops of all the objects. Okay, so now let's take a look at what happens when you look up at our cube. Our head is tilted upwards now. And once again, you have to ask yourself, where is the horizon? Where is your eye level? And because you're looking upwards, the horizon line is going to appear pretty low, all the way down here. So look at the room around you right now. Tilt your head upwards so you're looking towards the sky. Ask yourself, where is that horizon? You can only just see it out of the corner of your eyes, way down below. And then back to our cube here. The length of the cube is level to the ground, so the lines are receding back to converge at a point on the horizon line to the left. The width of the cube is level to the ground, so the lines are receding back to converge at a point on the horizon line over to the right. And now, because we are looking up, the height of the cube is no longer perfectly vertical. They're receding upwards to converge at a third vanishing point way above the horizon line. And notice how very far away that third vanishing point is. Here's some examples of things you may be looking up at. Pretty much anything very tall, up in the sky or towards the ceiling. You have to tilt your head upwards to actually see it. And notice how we are looking up at everything so we can see the bottom or underneath all of these objects. Here's an example of looking down in three-point perspective. Notice where our picture plane is. We have this box here that represents our drawing, but where is our horizon line? Because we're looking down, it's all the way out here, outside of the picture plane. So back when I said that you may not always be able to see the horizon line, this is actually what I'm talking about. Depending how far down you're looking, you may not be able to actually see the horizon line anymore, but it is still there. And then we have one vanishing point on the horizon line to the left, and one vanishing point on the horizon line to the right. And since we are looking down, that third vanishing point is all the way down there. In most cases, that third vanishing point is going to be super far away. But even though we can't see it, we can tell the height of our object is receding downwards and converging together. Those height lines are getting narrower and narrower as it gets farther away from us. Here's an example of looking up in three-point perspective. Notice where our picture plane is. That's the box that represents our drawing. But where is our horizon line in this case? It is all the way down here, outside of that picture plane. And depending on how far up you are looking, you may not actually be able to see the horizon line anymore. But it's still there. It always exists. And then we have one vanishing point on the horizon line to the left, and one vanishing point all the way to the right on the horizon line. And since we are looking up, the third vanishing point is all the way up there. Once again, that third vanishing point is going to be super, super far away. But even though we can't see it, we can tell the height of our object is receding upwards and converging together. So that about covers the basics. Now let's take a look at what this looks like in real life. So here we are again looking at our 3 cubes, and we are now in 3-point perspective. And what makes this scene 3-point perspective? It is because we are now looking down at this scene. My camera is now tilted downwards so it is facing towards the ground. And that is the big thing that you have to remember about 3-point perspective. If you are looking down, if your head is tilted downwards or tilted upwards in any way, you are in a 3-point perspective scene. So what is it exactly about having our camera tilted or our head tilted that makes this scene any different than anything else we've been looking at? And it all has to do with the height of our cubes now. Everything we've talked about so far, our cubes have all been perfectly vertical, perfectly straight up and down. You see, if I use my paintbrush as my measuring tool, I'm going to hold this out straight so it's perfectly vertical. And I'm going to put it up against these height lines. You can see how that line there isn't perfectly straight up and down anymore. It's at just the slightest of an angle. And if I look at every other one, it's at just a slight angle. And the farther away we get out from the center, the more tilted it is. So you can see how very tilted this one is off to the side. And that's because our head is tilted. We are no longer looking at the height of the cube straight on. It's not parallel to our face anymore. They're receding away from us. And this is often the most challenging that people have, and there's actually a few reasons why 3-point perspective can be challenging. First of all, it's kind of the hardest to measure. As I did when I measured out with my brush here, is that these angles are very slight. It's just a really slight tick to the side that makes it different. So when you were to measure this with cubes in front of yourself, sometimes it's very hard to see that little bit of angle on there. It's not as extreme as when we're dealing with our length and our width here. So sometimes people have a little bit of harder time trying to see where things actually are converging together. The second thing that can make this even more tricky is because up until now, every single vanishing point we've dealt with has been on the horizon line. And that was easy to remember. Your vanishing points are always on the horizon line. But now we all of a sudden have a third vanishing point that is not going to be on our horizon line. And sometimes that throws people off because then they're like, well, where is this vanishing point? And you have to remember that it's actually going to be directly below our cube somewhere. So when we're looking down, that vanishing point is going to be directly below the cubes. If we're looking up, that vanishing point would be directly above our cubes. So it's still going to be in our line of sight. It's going to be in the center of our page here. It's just going to be right below them, way, way, way down off the page. And it can be very, very far away. So let's take a moment and talk about the scene that we're looking at here. So the first thing you want to ask yourself is where the horizon line is. And this is where people tend to get tripped up in 3-point perspective, is they kind of forget all those rules we talked about where the horizon line is. When you are looking downwards, you're tilting your head downwards, the horizon line is still in the exact same place as if you were looking straight ahead. The only thing that's different is where we are looking. Try to remember what our viewpoints look like in 1 and 2-point perspective. Where was the horizon line on that scene? If you think about this background that we can see here, the horizon line was actually about 3 shelves above the ground. It was right around where that divide was in the cabinets, right above the top of the TV. And right now we can't see any of that. We can't see that divide in the cabinet, anything back there. So that's how I know that we can't see where the horizon is. It is outside of our sight. But there's other clues I can pick up from what we're seeing right now. Remember, everything below the horizon line we're seeing the top of, and anything above the horizon we're going to see the bottom of. And where I'm looking right now, I can see the top of the table. I can see the tops of all 3 of my cubes. I can even see the tops of some of these books back here in the background. And I can see even the top of a little shelf right there. But there's nothing right now that we're seeing underneath. We're looking down at everything. So that's a major clue. If we are looking down at everything, then we can't see the horizon. It's above where we are. So the big thing I always remind you to do when you're trying to figure out where your horizon line is in your room is to remember when I talked about filling that room with water. if you were in this room right now, if you were to fill it up with water all the way up to your eyeballs, and then you were to tilt your head so you were looking downwards, that water wouldn't move. That water level would stay the same. So right now, if you imagine this room filled with water all the way up to my camera on my phone, you'd have to notice that since we are looking down, we are looking underneath the water right now. So everything we're seeing is submerged underwater. That means it's below eye level. That means it's below the horizon line. So really try to put yourself in that scene if you're ever confused about where the horizon line is. But we can also use other information in this scene to tell us where our horizon line is. We know that any lines that are level to the ground, parallel, and receding will converge at points on the horizon line. So I could measure the width of my cubes. We know these are receding away from us because they are at an angle. So if we were to follow these cubes, these lines are pointing all the way up towards the right. And the bottom of the cubes are pointing all the way up towards the right. And we can even look at the edge of the table back here. It is pointing up towards the right. So we know they're pointing upwards. They're going to converge at a point that is up off towards the right on the horizon line. Then let's look at our other information here. Let's look at the length of our cubes, the pink lines here. These are all receding back that way. And these are actually a little bit easier to see because you can definitely see they are pointing to a spot that's above our page here, if you follow to where they would converge at. And remember, we can use the lines on the table too. We could follow these lines to where they are pointing to. I like to think of these lines as like arrows. All of these receding lines, they are arrows that are pointing to where our horizon is. So if we know these pink lines for our length are pointing to a spot all the way up there, and our green lines for our width are pointing to a spot on the right all the way over here, then we know the horizon line is up somewhere that is off this page. And I just took a quick little moment here and I followed all of my receding lines so you could see exactly where the horizon line is in relation to this picture. So it is above and outside of our picture plane, just like I thought it would be. So we have figured out the length of our cubes are receding back towards the left of our page and converging at a point on the horizon line outside of our picture plane. So then where is our third vanishing point? The third vanishing point has to do with the height of our cubes now. This is the one thing we haven't had to deal with yet, is the height of our cubes. We've been able to ignore it up until now, essentially. So now all we need to do is follow them to where they converge to. And since we are looking downwards, that means our vanishing point is going to be down. It's going to be in the direction we are looking. If we were looking upwards, the vanishing point would be up. And this is something people tend to mix up as well. So really try to remember, the third vanishing point is in the direction you are looking. And you can figure that out by using your measuring tool and try to find where these lines are converging to. Here's vertical. If this line was totally vertical, we can see this is tilted off towards the left here. So that means it is pointing in towards the center here. If we were to follow the rest of these, now they're all of a sudden tilted the other way. And they are pointing towards a spot in the center. Because you remember that the third vanishing point is going to be in the center of our page. It's going to be below our cubes. And so these are all pointing inwards towards that third vanishing point. That's going to be way, way down below our picture plane here. So sometimes people can get a little bit confused about which way that third vanishing point is, if they can't remember if it's above or below. So the best thing to do is just follow those height lines all the way from the top to the bottom of the page, and then take a look at the angle of them. You notice that these lines are actually converging. They are getting closer together towards the bottom of the page. As compared to the top of the page, where you look at these lines, what's happening? They're getting farther apart, and that's not what converging is. We're looking for converging lines. So just by looking at the angle of these lines, we know that the vanishing point is going to be directly below these cubes, way down towards that bottom, where these lines are converging to. And I want to bring up one more thing about three-point perspective that tends to be a little bit confusing. And it has to do with the orientation of the objects towards us. What makes three-point perspective what it is? It all has to do with that tilt of our head if we're looking up and down. It really doesn't matter how our objects are oriented to us. So right now I have all of these cubes so that the edge of the cube is closer to us here. So right now we can see all three of these lines receding away from us. But what happens if I was to rotate this cube? Okay, so now this cube I have in front of us, the width of our cube is now horizontal again. Just like back when we were in one-point perspective, right? We're looking towards the front of face of the cube. The horizontals are all perfectly horizontal. So what does that mean? Technically, right now, this cube only has two vanishing points. The length of the cube is receding towards a vanishing point on the horizon back this way, and the height of the cube is receding towards a vanishing point down this way, but the width of the cube is not receding, so there's only two vanishing points. However, we still consider this a three-point perspective scene. So I know it may seem confusing because it technically doesn't have three vanishing points, but the big thing you have to remember about three-point perspective is that it really has to do with the tilt of your head if you are looking up and down. That is the true thing of what we consider three-point perspective to be. So we still consider this three-point perspective, and we consider this three-point perspective, even though, this one has three vanishing points that we can see, and this one has two vanishing points we can see. And they can exist in the same picture at the same time. So sometimes I like to consider this as a one-point perspective cube in three-point perspective, and this is a two-point perspective cube in three-point perspective. Not like that's confusing anyway at all, but I do want you to know that the orientation of the object does not matter. This is still a three-point perspective scene no matter what. And that's the length of the cube is level to the ground. Where is our horizon line? Away from us. We are looking down at our objects. That means our horizon line is up that is outside of our picture plane. It's outside of the picture plane. The width of our cube is level and receding away from us and converging at a point on the horizon line off to the right outside of our picture plane. And the height of our cubes are receding downwards because we are looking down, and they're converging at a point below us outside of the picture plane. And they are converging at a point directly below us outside of the picture plane. And that's it. We now have all three sets of receding lines, so we are living in a three-point perspective world. And as challenging as I know three-point perspective can be, in your everyday life, if you think about you walking around the world, chances are you're mostly seeing the world in three-point perspective. How often do you always have your head looking straight ahead? And how often are you really looking up and down? We really look up and down a lot. So most of the time we are seeing the world in three-point perspective. It's a world that has a lot of depth because all the sides are receding away from us. So even though it is the most challenging, I do think it's important to know how to do three-point perspective. So then you're not limited in any way. You can draw the world around you in any way that you may see it. And that's it. Next up, let me show you how to draw three-point perspective.